Yeah, so we remember when we in Math 101 when we took the derivatives, we saw that the derivatives they mean the slope. One of the meanings, one of the interpretations is that it is the slope of the tangent line. Now the partial derivatives we saw also they represent the slopes of tangent lines, but in a certain plane, But now we want to find the tangent planes, Now, so just remind you what we did last time. This is the GeoGebra. Remember, we explore this. Okay, so let me hide these guys here. Let's assume we have a surface. Let's, if you see this green point, this is the point A. And we said that, well, let's take a plane x equal 2, okay, the plane that goes through that point, and it is vertical on the xy plane, so it is have it this way. And then we said, okay, let's take the intersection, this one. When we say this plane, we cut the surface, we got this curve, the blue curve here, okay. So if I view it this way, like this, and hide these guys here, okay, this and the plane, you are seeing a curve in two-dimensional space, okay, an xy plane. You can think of it this way. And then you see this point here. When I take the not this one, actually this one. When I take this line here, when I take the partial first partial derivative, then I get the tangent line. Okay, that's what we know it in Math 101. This is the tangent line. And the slope of this tangent line, since we put the curve x equal 2 in the beginning, so it will be the derivative with respect to y, partial x by partial y, evaluated at the point A here. Similarly, if we have this surface, and instead of x equal, no, I make y equal to, for example, y equal the y coordinate of that point, then the intersection becomes this, yeah, the blue one. Okay, you see the blue curve here, and then okay, and then if I remove these guys here and the plane, so we have this curve in two-dimensional. You see the point A here is equal to, actually it should go this way here, because the x-axis will need to be positive in the right and the positive up, negative left. So this is exactly what we know in Math 101. So when I find the derivative with respect to x, it turns out it is the slope of this tangent line. Now the question is this. So let's take all of these away. Remember, so far we found two tangent lines like this. Two tangent lines, one derivative with respect to x and one derivative with respect to y. Okay. Now the question is this. Can we find a plane, if you see this blue plane, that contains these tangent lines? And as you see, this plane here touch the surface at the point. Touch the surface at the point. Okay, I can show you in different angles. Okay, touch the surface of the point. So this is what we call the tangent plane. So our objective, one of the objectives of this section, is to find the equation of the tangent plane. The equation is very nice and easy to do. So so let's assume that I have, okay, let's go back to the presentation here. So let's assume that we are talking about, of course, in z equal f of x and y, okay, a function of two variables at the moment. So where f is a continuous and has partial derivatives, take a point on the surface, x naught, y naught. Of course, z naught is when you substitute x naught, y naught in the function f. Let's take C1, C2 be the curves obtained by intersecting the vertical planes y equal y naught, x equal x naught. If you remember the intersections that what we did, we are talking about these curves here, the blue curves. These are the curves he's talking about here. Now, the point, of course, P will lies in both curves C1 and C2. T1, T2 are the tangent lines to the curve C1, C2 at the point. So the tangent plane of the surfaces at the point P is defined to be the plane that contains both tangent lines T1 and T2. This is exactly what we saw in GeoGebra now. But this is just illustration in the textbook, but it's better to go through the software. Now we want to find the equation of that plane. And let me hide it, just leave it away here. And let's take it, this guy here, and nope, I need this guy here, okay? And I need this guy here. So I assume you can see both of them, the paper and the plane here, okay? Fine. Can anyone remind me what is the equation of a plane? If a plane, plane passes through point x naught, y naught, z naught with normal vector, let's say a comma b comma c. Remember, we took the midterm shabab last week. Yes, Rakan.
ax minus x naught.
Ax minus x naught plus cy minus y naught plus cz minus z naught equal to 0. Thank you very much. So this is what we took in the previous one. We will rearrange this this equation. I will take these two terms in the other side. So we have this minus a x minus x naught minus b y minus y naught. Okay. Next, I'm gonna divide by c. Okay. So this is minus a over c, x minus x naught, minus b over c, y minus y naught. Okay. Right. Next, now I'm gonna replace these guys here by another constant. So let a, capital A equal minus a over c, capital B equal minus b over c. So what will be the new next version of this equation is z minus z naught equal capital A x minus x naught plus capital B y minus y naught. Okay? Okay, so now what left for this equation to be really identify the plane? If I find A and B, okay, because it's Z naught, X naught, Y naught, these will be given. These are the points. If you see in the program here, the point A. This is the green point here. Okay, this is the point A. This is, we know the coordinates here. Right? We know X naught, Y naught, Z naught. So we have it. Now what left is A and B. If I found what is A, what is B, I'm done. I found the equation of the plane. So how to do this? Well, now notice that we have two tangent lines, okay? So when, let's say y equal y naught, yani on the plane, y equal y naught. Now remember, Shabab, when y equal y naught, let me do it in the software. So let me hide these guys, this guy, y equal y naught, yani we are talking about this one, and we are talking about, not this one here, okay, this one here, okay, remember what happened here? Let me hide this surface here, Shabab, let me hide this one, okay, Shabab, what happened this one? Now look at the equation. Let's substitute in the equation. And let's see, match it with what we saw, what we are seeing in the program. So let's put y equal y naught. When I put y equal y naught, this one will disappear. So we have z minus z naught equal a times x minus x naught, right? Now from the figure, we see that. Now if you look at the figure, Shabab, in the GeoGebra, you have the tangent line to the curve at the point A. So imagine this red axis is the x-axis, and imagine the blue arrow, the z-axis. So we are dealing with two variables, x and z. How to find the equation of this tangent line? What is the equation of this tangent line, the black one that passes through the point A? Can anyone tell me?
The slope of the
So first of all,
derivative of the
yeah, so first to write the equation of the tangent line, remember it is y minus y naught, right? But instead of y, we're gonna say z minus z naught equal the slope. So I'll put here, I will write the slope just to remember. What is the slope of that line? Remember, we are in the plane y equal y naught. Yani making y is a constant. So what will be the slope? Derivative with respect to anyone?
Y.
No,
To
y is a
x.
constant. X, okay? Yani we fix y, so that means the other one x. So it is if x, derivative of x with respect to x, evaluated at the point x naught, y naught, times x minus x naught, okay? So just remember in Math 101, this is in Math 101, you have y minus y naught equal f prime of x naught, x minus x naught. This is from Math 101, as we know. But of course, f prime, because we have only one variable, but now we have two variables, so we have to specify the variable that we are differentiating with respect to. So we have derivative f with respect to x, x naught, y naught, times x minus x naught. طيب, let's match this with this one. What do you see يا شباب? We see that
A equals rho.
أيوه, A equal this guy. Equal this one. So خلاص, we know A, this A, we know it is this guy here. If the derivative with respect to S evaluated at x naught, y naught, this will be constant. And we substitute everything, this will be constant, so we find. Similarly goes for B. Similarly goes for B. What we will do, we'll say let x equal x naught. So x equal x naught, so this will disappear. So we have a z minus z naught equal p y minus y naught. At that plane, when x equal x naught, if you look at the software, the same idea here, x equal x naught. So so you will take this intersection of plane. Let me hide this line. Okay. No, not this one actually. Not this one. This one actually. Yeah. This intersection plane. So we are talking about this curve, and you will have this tangent line. Hide everything just to make it clear for us. Yeah. So we are talking about this. So this is the y-axis, the green one. The blue one is the z-axis. How to find the tangent line passes this point? You gotta say derivative with respect to y. Why? Because we're making x as a constant. And then you are gonna have b similarly. I will write here similarly. B equal the derivative of f with respect to y, x naught comma y. طيب, what will be now the equation of the curve? It will be z minus z naught equal derivative with respect to x at evaluated x naught y naught plus b, which is this one, derivative of f y evaluated x naught y naught times y minus y naught. Okay, which is this one, which is this one, z minus z naught equal derivative with respect to x, this. Okay. Any question here, شباب? طيب. So it is nice and easy to see this tangent planes. Now let's have an exercise. Find an equation of the tangent plane to the surface at the point this one. Okay, so remember z minus z naught equals evaluated at x naught y naught x minus x naught plus derivative with respect to y x naught y naught y minus y naught. You notice, Shabab, this is like a more it is very similar to the equation that we learned in Math 101. If you look at the Math 101, this is the equation of the tangent line. This is the equation of tangent line, y minus 9, these guys here. You see z minus n, because z is the dependent variable that depends on x and y. So we are putting the dependent variable on the left side, equals derivative. You see, derivative. But now we have two derivatives, two partial derivatives actually. So we have a derivative with respect to x times x minus x naught, derivative with respect to y times y minus y naught. So it is kind of extension to this one, Shabab. Okay. طيب. Now, okay. Now, what we do, يا شباب, he said z equal 2x square minus y square plus 1. Okay. I believe, يا شباب, there is a attendance quiz. Please do it now. There is a attendance quiz. Please go do it now. طب اشتغل. Now he gave you the point 1 and 2, so these are the guys here, x naught, y naught, z naught is equal -1. These numbers are picked from the point because he told me the question evaluate this point. And by the way, شباب, when you substitute x naught, y naught here, you will get the z naught, which is the value of the function at these 2 points. Okay, so even if he gave you only x naught, y naught, you can't find the z naught. You can't find because you just substitute in the function, you will get the z naught. Okay. طيب, let's remind ourselves the derivative with respect to x. What is derivative with respect to x يا شباب? Anyone?
4x.
ممتاز. 4x. طيب, so this implies that derivative with respect to x evaluated at 1 and 2, which is equal to 4. طيب, derivative with respect to y?
minus 2y.
Minus 2y. So derivative with respect to y evaluated at the point 1 and 2, which is equal to minus 4, right? طيب, so the equation of the tangent plane is z minus z naught is this, so it is plus 1 equals the derivative with respect to x, which is this one evaluated, so we have 4 x minus x naught is 1, and then the derivative with respect to y, which is -4, y minus y naught, y minus 2. Okay, so this implies that z equal you have 4x -4 minus 4y plus 8, and then minus 1. So at the end you will get 4x minus 4y minus 4 plus 8, which is plus 4 minus 1, which is plus 3. And this then any question here, Shabab? Yes, Faisal?
Doctor, can the variables change?
What do you mean by change?
Here we have z equal to x and y. Can it be x equal to z and y?
You are saying that we are assuming z equal, yeah.
Yes.
This case, z equal. What happens if x equal? Yeah, you can do the same thing.
It will be the same.
Yeah, the same thing. Yeah. Okay. Yeah, we are saying z equal, but you can, if the surface is moved, the other axis, yeah, you can think of it this way. Okay, but always keep in mind z equal, not z square, not z cube, not a function of z equal to a function of x and y. Z equal, one variable is solid like this, depends on the other. Okay. طيب. Yes. Any other question?
دكتور دكتور, now the z naught, we said that it's equal to -1 because given in the question, or because in the equation -1 we can't move to the other side.
If I'm saying if he didn't give you, he told you x and y only, x naught, y naught. Can you find z naught? Because you need to substitute it here.
Yes, I can.
You can, right? So you substitute 1 and 2, you will get -1.
Okay, Doctor, type, if he gave me maybe z naught 2, so I should go with 2.
If he told you z naught equals some number, but you need to just check when you substitute x naught, y naught in the function, does it give you z naught? Because if it doesn't give you this z naught, that means this point is wrong. It's like he asking you to find tangent plane on the point that point is not on the surface. Right?
Okay.
It's like in Math 101. You remember sometimes he gave you a point, sometimes no, he gave you only the x coordinate.
Yes.
Okay. So similar situation here. Okay. Right. Okay, Shabab. Right. So let's continue on this one. So this is the final answer. I wrote it here. Now, the second part of this section is about linear approximations. Linear approximations. You remember in Math 101, we took it in section, if I'm not mistaken, 3.10, where we approximate the difference or the change in the function f by the dy and df here. Here, in the function of two variables, assume that z is equal fx and y, be a function that has continuous first partial derivatives fx and fy, okay, at the point x0, y0. The linearization of f at the point x0, y0 is given this way here. If you look at the right-hand side, Shabab, if you look at the right-hand side, this is the equation of the tangent plane. This is the z0. هذا الfx y0 y0 هذا z0. This is z0. And the rest is exactly what we saw it in the previous slide. This is it. Okay. So the equation together on the right hand side, we think of it as a linearization of f. Linearization of f. And the linear approximation, or sometimes people they call it tangent plane approximation of f at the point P, is given this way. That sometimes instead of substituting to the function f, I will substitute in this plane. Lx and y, okay, this function, which is a plane actually, Lx and y. So f of x and y approximately equal to this equation when x and y is near to x0, y0. And keep in mind, Shabab, when I'm saying approximately, there is an error going on. The error will be small if x and y is close to x0, y0. If xy, the point xy far from x0 and y0, the error will be bigger. Okay. We did this in Math 101 in one dimension. Sometimes substituting in the function itself is difficult, so we go and approximate it by that tangent line. In this case, we have the tangent plane. So let's take a question like this. And also, let me, before I solve the question, just a matter of convention, let's have this. And before I go ahead and solve everything, yeah. So this is the tangent plane, Shabab, okay? This is a tangent plane. See, this is a tangent plane. If you notice, I'm putting x plus y minus 2 because I calculated it. I calculated the equation of tangent plane. That's why I found it. So this is the point. Now the idea is this, Shabab. When I am close to this point, okay? In the program, he put it separate white, but they are touching, actually. If I am very close to this point, any point here, I can approximate the value of this point by just substituting in the plane itself. So this is the point. This is the idea. The whole idea like this. Okay, so let me just yeah. So we have it this way. So instead of substituting in the surface, no, I will substitute in the plane. And you see that the plane is a linear equation. When I substitute in there, things are better. Okay, so here it says find the linearization of the function fx and y given this way at the point 1, 2, and he said estimate the value of this function f at to 1.01 and 1.98. Now imagine you're taking these numbers and substitute here, Shabab. It will stuck, right? It will stuck, unless if you are using calculator, that's something else. But you're gonna stuck in this way. So. Okay, let me just do it this way here. Yes. So now I want to find the linearization of the function f. The linearization, which is Lx and y, which is equal to f of x naught, y naught. It's like equation of the plane. And let me just remind you, Shabab, what we did. This is the equation of, you need to remember one thing and the others will come conclusion. Had is z minus z naught. If you put it in this side, it will be this. And the rest is exactly the same. So it is plus fx x naught y naught times x minus x naught plus f derivative with respect to y x naught y naught times y minus y naught. Okay, so now we have it this way here. Right. Now, what I need to do, I need to find this, that. So now, if you look at the function f in the bottom here down, so we have f of x and y. No, I don't need to write the function actually. This pen is also dying, so I have to pick another one. So now, derivative with respect to x يا شباب. يلا بسم الله. Anyone? Yes, محمد تفضل.
y square
y square
plus 2xy.
No, we differentiate with respect to x. So that term you have y square only. What about the other term? The cosine. Yeah. What is the derivative of cosine?
Sine.
Yeah. But the times derivative. Yeah.
Yes, y sine x minus 1.
Okay, this is what we have. طيب, give me the derivative with respect to y.
2xy plus cosine x minus 1.
Okay, very good. Thank you very much. طيب, now this evaluated at 1, 2. You just substitute يا شباب. So we have 4 minus here يا شباب when I substitute x هذه x naught يا شباب. Just to keep in mind, this is x naught, y naught. When I substitute here, so we have 0, y. Okay, so we have 4. Here, 1 and 2 equals, when I substitute here, so we have 4 also. Plus, when I substitute x equal 1, you get cosine 0 to cosine 0, 1, so we have 5. طيب يا شباب. We forgot this f1 and 2, okay, because I need to substitute at this point. So f1 and 2, this will be equal to 4 plus cosine 0, 1, so it will also be equals to 5, right? Now, no, actually 2 here.
4
so 6. Yeah, so 6, right? Yeah. Now, so this is, yeah, so now the linearization of f at the point P, 1 and 2 is L of x and y equals, now, okay, let me just bring it a little bit down. Yeah, this one, we said this is 6 plus fx and y, which is 4 times x minus x naught is, you gave me the 1, plus fy, which is 5, y minus y naught, which is 2. Okay, so I have this. So let me just highlight this. This is what we need. But we can simplify it more by saying this is 4x plus 5y, and then you have negative 4 and 6, you get 2 and negative 10, so you have negative 8. Okay, so you can have this, you can have this version, but I prefer this version here, Shabab. Okay, any question here so far? طيب. I think we did it here now. So oh yeah, we didn't continue this one. So let me continue. Sure. Because what we did, we solved part A. Okay. Now part B, it says estimate the value of this function. So we want the value of the function at 1.01, 1.98. Okay. Now I'm gonna estimate it by substituting these numbers. Okay, sorry, I forgot here. 1.98. Substituting this point into the plane, the tangent plane, which is L. Now, if you see here, this is the equation of the tangent plane. So instead of substituting here, Shabab, and because of the hustle of the calculations, I will substitute here. It's better. Why? Because x minus x naught will give me the difference in the change in x. And you see the change is 0.1, right? And the change in y is, you'll find it is a very simple number here. So you're going to say this, 6 plus 4 What is x? This is the point minus 1, and then plus 5 y 1 point, and be careful of the order, because you're gonna have a negative sign here. Okay, so this is what we did. Now let me just remove a little bit up here. Now this is equals 6 plus 4 times. If you see, notice this, you get 0.01, and then here plus 5 times. If you notice the difference, this is negative, negative 0.02. So this will be 6 plus, here you're going to have 0.04 minus 0. You know that it will get 1 or 10 if you want, that's fine. And this is will be 6 minus here what you will get, ya shabab, you will get 0.06, and this is will be equal to 5.94, right? Because of 4 you get 1 and you get 6. Okay, so the value of the function is approximately equal to 5.94. Okay, any question here, Shabab? Yes, Muhammad?
If he say find the exact approximation or estimate the exact value.
The point is that we cannot substitute in the exact value. So let's assume we cannot find the exact value. Okay, we cannot find the exact value, Muhammad. What we did, we estimated. You want to find the exact value, substitute these numbers in the function. Look here, you have cosine. So what is cosine of 0.01, for example? Then x and y squared, that's fine. You can multiply and divide, but you have a problem at the cosine. What is cosine of 0.01? Here you need to think a way how to find it. Maybe using Taylor series or whatever.
So, doctor, okay, if it's if the equation similar than this, I can calculate the exact value.
Yeah. If it is simple, you can do it. But the idea is that what if the function is a bit complicated? Okay, a little bit complicated. So we go through the tangent plane. We approximate by taking the tangent plane itself. Okay. طيب, any other question? طيب. Now, yeah, so these are the numbers, and we get the final answer this way. We are still in the linear approximations, but we're going to generalize the idea into functions of 3 variables. So if you have a function f(x) and y and z, a function that has continuous partial derivatives with respect to x, with respect to y, with respect to x, z, sorry, at the point x0, y0, z0, then the linearization point is giving this way, and you notice that we're adding another term for z, okay, for z, and so we have this equation, but we're not going to call it plane, just leave it this way because we have to create dimension for dimensional space, and the linear approximation of f at p is this one. We can use it this way here. طبعا, what if the function is a function of 4 variables? You're going to add another 4th term here. 6 variables, you add derivatives up to that 6th variable here. Okay, so we have this, and here I told you please find the realization of this function at this point. You just substitute exactly what we did, and the final answer will be this is the linearization. Okay, you follow the same steps, you get this one. Okay, طيب, any question here, شباب? Now we are in differentiability. Okay, we are in the differentiability, and remember in Math 101, ya shabab, Math 101, when we say a function that is differentiable at the point, we didn't speak much about it because if the limit exists, then we say the function is differentiable at that point. The limit of, remember the h, or the definition using h, or the definition like the slope, the function exists. But we never talked about differentiability in functions of 2 variables because we started talking about the partial derivatives. It has a partial derivative or does not have partial derivative. Now we're going to talk about the differentiability. When I say a function of 2 variables is differentiable, so this is the definition here, or we are coming to that. So consider the function Okay, just a moment. Okay, so consider the function z equal fx and y. Then if a point moves from x0, y0 to x0 plus delta x, y0 plus delta y, the corresponding change in z is obviously will be this one. Okay, the value function at the new point minus the value of function at the previous point, which is this one. Okay, we'll give you the change in a. What happened to that change in z? Okay, now a function z equal f of x and y is differentiable at x0, y0 if the partial derivatives exist and delta z satisfies an equation of this form. F of x derivative partial f by partial x evaluate x0, y0 times delta x plus partial f by partial y x0, y0 delta y plus epsilon 1 delta x plus epsilon 2 delta y, in which each of these epsilons approach to 0 as both delta x and delta y approach to 0. If this delta z satisfy this equation, we call f differentiable if it is differentiable at each domain, and the graph we call it smooth surface. Now, probably you never seen epsilon 1 and epsilon 2 in Math 101. Most probably you did not see the epsilon 1 and epsilon 2 here in Math 101. And let me show you where these came from. I will show you in one dimension. And in a similar way, in the textbook, he put it in the index here. Okay? So in one dimension, in 1D, y equal f of x. And let the point P, which is x0, y0, point in the plane, on the plane. طيب؟ يعني P x0, y0 اللي هي شباب f of x, right? We have it this way here. طيب. Remember يا شباب delta y, which is equal to, now assume, يعني let's assume that you have the point x0, y0, you move to another point, let's call it x0 plus delta x. Okay, يعني the x0 you move it, يعني you move it to another point, and this will be f of x0 plus delta x, right? So you have this point here, and this is y0, which is f of x0. Okay, شباب. طيب, delta f it will be, delta y will be f at x0 plus delta x minus f at x0, right يا شباب? Anyone? You have any question? Delta y, the change in y is the value function x0 plus delta x minus fx0. Okay? طيب, what is dy يا شباب? You remember the differential of y? In Math 101, يعني I'm talking about one variable. What is dy?
f prime.
F prime, let's say at x0, dx. Okay? Do you remember, شباب, that if I want to find the change in y, I approximate by dy, right? If I want to find the change in y, sometimes I approximate it by dy here, okay? When I say approximate, there will be error. So let's call it here error, okay? Error of approximation, or let's say like this, approximation error. If I want to measure this error, شباب, what I will do, I will say delta y minus dy. Okay, أكيد يا شباب اللي هو exact will approximate it. When I take the difference, it will give me the error. This is the basic concept you learn in everywhere. طيب, so let's say delta f minus df. يعني if I want to change y by f. Okay, why? Because I want to generalize later, يعني this function f. طيب, what is delta f يا شباب? Which is this one. Okay. ترى مجرد غيرت النوتيشن يا شباب, بدل y حطيت f, just replace y f, that's it. So now this is x0 plus delta x minus f of x0 minus, and I just substitute delta f, df, the differential of f, which is this guy here, which is f prime of x0 dx. Okay, now let's continue here. Okay, so remember this is approximation error, which is delta y minus dy equals, we reach at this step. So now f of x naught plus delta x minus f of x naught minus f prime of x naught. Remember يا شباب delta x I can replace it by dx. يعني this is by default. We say the change in x, I just put it equal to the differential of x, or differential of x equal to the change of x. Exactly, we put them equal. Okay, this is in Math 101. We set these together. Now, I take dx as a common factor. Okay, I take dx as a common factor. Delta x, I mean here. Delta x as a common factor. Here I have f prime of x naught. Here, يا شباب, it will be a quotient. So f of x naught plus delta x minus f of x naught over delta x. So we have it this way here. Okay? واضح يا شباب؟ طيب. Please look at this quantity between these two brackets. Okay? And let me do it in a new line. When delta x approach to 0 لما يكون التغيير في الاكس صغير جدا يا شباب. اوكي؟ ابغاكم تشوفون الكوانت هذا بالذات يا شباب. What is the limit when delta x approach to 0 f of x naught plus delta x minus of x naught over delta x. هذا ايش يساوي؟
انفينيتي.
تقريبا انفينيتي.
لا انا بتكلم الجزئيه هذه. No, not infinity. طيب. What if I change it into let me just bring the black pen. One. What if I change it to يعني هذه خليتها h approaching to 0 وسميتها h وسميتها h. ايش حيصير هذا؟ يا شباب هذا الليمت.
زي
خلينا
الليمت فارم.
يس وليد.
نفس الليمت فارم حق ال 101.
Yeah, what does it give?
0/0.
Yes, 0/0, but okay, let me write it again in a new paper. Limit h approaching to 0 f of x naught plus h minus f of x naught over h.
dy over dx.
This is derivative of f evaluated at
x
naught. x naught because we are putting x naught. Okay, شباب؟ فهذه الريد هذه the same as f prime of x naught. Okay. طيب الآن نشوف يا شباب when dx gets small, this quantity it gets closer to this f prime x naught, and we are saying minus f prime of x naught. So that means this quantity يا شباب, this quantity is getting smaller and smaller. The whole quantity between brackets is getting smaller and smaller. So since it gets very small, I will call it epsilon. So this is equal to epsilon delta x. Okay, why? Because this in between brackets, when delta x gets smaller and smaller, because the difference in x gets smaller to 0, this goes to derivative of f at x naught, but minus the same derivative of x naught. So this means the difference here is gets small and small. So we are saying just put it equal to epsilon. So we have epsilon delta x. So therefore, if you look at this equation, delta y minus dy is equal epsilon delta x. This implies that delta y is equal dy plus epsilon delta x. بمعنى آخر, this is f prime x naught dx plus epsilon delta x. Remember يا شباب يعني we are saying delta dx I can replace it by delta x plus epsilon delta x when can you see? Yes, you can see. When delta x approach to 0, epsilon will approach to 0. Okay, approach to 0. What we did, Shabab, we did in one dimension. This part, maybe you did not see it in Math 101. At least when I taught it, I didn't go to these details because we don't need it, this idea. But in Math 201, we need it just in definition, defining things. So we say that y is differentiable if delta y can be represented in this way. If delta y can be represented this way. Keep in mind, this is a point. Delta x is x minus a. So this is a variable here. Here epsilon. So if the delta y every time is equal to this one, we say y is differentiable, but we did never say this before. Now, in case of two-dimensional space, now you have derivative with respect to x, evaluate at the point x naught y naught delta x, and you have derivative with respect to y, x naught, evaluate at x naught y naught times delta y. Now we have two epsilons, one for x and one for y. Okay, so both epsilons, epsilon 1, epsilon approach to 0, as both delta x, delta y approach to 0. Okay, if delta z, you always have it, then we say this is differential. Now, if you look at this, Shabab, it looks difficult to verify the function is differentiable or not. Luckily, we have this theorem. Actually, it is a corollary of a theorem. Corollary, Shabab, means a result of a certain theorem, a conclusion of a certain theorem. I didn't write the theorem, but just I took this result. Some people, they consider it a whole theorem together. Okay, but anyway, we have this statement. If the partial derivatives, derivative f with respect to x and derivative f with respect to y of a function f are continuous throughout an open region R, then we say f is differentiable at every point of the R, of the region R. The region R, it could be disk, it could be rectangle, it could be anything, any region. So in other words, if the partial derivatives are continuous at any point, then we say the function is differentiable at that point. Full stop. Okay? So this is it, very simple thing. So I don't need to go through all of these hustles here. Now, and also we know for Math 101 that if function is differentiable, then it is continuous. We have it here now. We say f of function is not y. Now we can relate these two together, combine them in one statement. We can say that if the partial derivative of x with respect to x and partial derivative of f with respect to y are continuous at the point x and y naught, then the function f itself is continuous at that point. It's continuous at that point here. Okay. Type. Any question here so far, Ishmael? So in this example, he said show that this function is differentiable at the point 0, 1. So let me just do it this way. Okay, so if you want to show it that it is differentiable at 0, 1, what I will do, Shabab? Okay, what I will do, I will find the partial derivative with respect to x. So first times derivative of the second, so we have this, plus derivative of the first times the second, which is this one, derivative with respect to y. So you have x, y, a, x.
دكتور معليش attendance quiz.
Yeah, the attendance. Please go do the attendance, Shabab. Please go do the attendance. Please go do the attendance quiz, Shabab. Okay. طيب شباب. Now, what do you think of these functions, Shabab? Continuous at the point 0, 1. Why are they continuous at the point 0, 1, right? Because I can substitute 0, 1 without any problem here. So this implies that f of x and y, which is equal to x exy, is differentiable at the point 0, 1. That's it. Very simple thing. Just check the partial derivatives. If these are continuous at this point, خلاص, you are done. Okay? Any question here, Shiva? Good. Now, let's talk about the last part of this section, which is differentials. Differentials here. Remember in Math 101, and just we spoke about it a moment ago, that dy is equal f prime of x dx. This is the differential. Okay. And remember in Math 101 also that if you have a curve y equal f of x, what does it mean differential? What does it mean delta x? And delta y and dy. Delta x dx, we make it equal. So we see here he make them equal. Delta y, it means that the change that happened in y when x is changed. So assume you have a point A, you add delta x, a plus delta x, so you make a change in a. Of course, you have a point on the curve, so you're just measuring what happened to the change of delta y from this point to this point, the value function at a to the value function at a plus delta x. Okay, and the dy, it measures or gives you the change that happened from the point A to the value at the value of the linear this way. So you substitute this point at the tangent line, so this will give you dy. And then we say that, well, we can approximate delta y by dy. Yeah, let's say if you are, notice that when I'm getting closer to the point, the difference between the graph and the tangent line is relatively smaller and smaller. Getting smaller, we're going to get closer to the point from this direction or this direction here. But what will happen in case of function of two variables? So for a differentiable function of two variables z equal fxi, we define the differentials dx dy to be independent variables, and then the dz, we call it the differential dz, or, and this is most common, I think, later in literature, we call total differential. Total differential is defined this way: dz is equal partial f by partial x times dx plus partial by partial xy times dy, or we can write it this way here. Okay, this is equation 10. So this is the way, and in geometry, this is what does it mean. You have a surface z equal fx and y. You have a tangent plane, the yellow, almost like yellow or brown one. This is the tangent plane, and the tangent plane touch the surface at this point AB, and of course we evaluate AB at the function, so we have FAB. So this is the point here. They touch the surface touch at this point. Now what is delta z? The difference between, if you're assuming the point AP, you moved it to here in the xy plane. You substitute a plus delta x, b plus delta y. You substitute in the function and the surface, you get this point, okay, which is exactly this point here. Now what you will do, you want to measure the difference in z, and you go to the z axis here. You measure the difference. This is the delta z, the change in z, the change in z. The same thing, Shabab. We take this point, we substitute in the equation of the tangent plane. And he gave you the equation of the tangent plane. I can substitute this point, a plus delta x, b plus delta y. I substitute here, okay? And then I get a point. The difference between the point and the on the tangent plane and the original point, this is we call dz. Of course, we're gonna approximate. We're gonna say that approximate delta z by dz because they are relatively closer to each other when I'm getting closer to the tangent point. Okay. So usually we take dx equal delta x, and here also, Shabab, we take dy equal delta y. Okay, so both of them we make them equal. Now and then dz we approximate it by delta z, or the difference or the change in f, df, the differential of f, we can take it as the difference in f. Of course, we want to find this, so it will be easier to find the derivative of the differential. This is the general case, Shabab, if we are dealing with function of three variables. If w equal f of x and y z, then the increment of w, the delta w, the change in w, we mean, so we're giving this way, and the differential dw is defined like this. So you notice that we're adding another term for z, with respect to z. Okay, Shbab? Now let's come back to do dimensional, three-dimensional space. When you have z equal f of x and y, so we have this one. So usually we put dx equal delta x, as we know, but delta x we put it x minus x naught because we are relatively saying the change in x naught, and delta y we're putting y minus y naught. Then dz is equal, we're just substituting, Shabab, delta dx dy. We are substituting what we said here, so we have it this way here. And this will give an estimate to the increment delta z when the point x naught y naught moves to this point x naught plus delta x, y naught plus delta y. Okay, will tells you the change that happened in delta z. So here in this between parentheses x minus x naught, this is a change in the x coordinates. Y minus y naught, this is the change in the y coordinates here. Okay. طيب let's take an example. Let z equal this. If xy changes from 2.3 to 2.05, 2.96, then estimate the resulting change in z. Estimate the resulting change in z. So let's have it here. Okay, and I will just put in the top here. I will write what we have. We have dz equal f of x, x naught, y naught, and then x minus x naught plus derivative partial f by partial y, x naught, y naught times y minus y naught. So we have it this way here. Okay. Now, so let me move it a little bit up here. So nope, not this one. Yeah. So yeah. So we have it this way here. طيب. Now, what we need to do يا شباب? We need to find the partial derivatives. Okay. And keep in mind, Shabab, this is what we want. We want this, the change, the resulting change in z. But I want to approximate it by dz, which is this one here. Okay. Now, to find delta z, just to show you how to find the exact value, you need to find the value. You substitute the point 205, 2.96 in the function, and then substitute 2.3 in the function, and take their difference. Okay. But assuming this calculation is difficult, so we go with the dz. So, what is the derivative f with respect to x, Shabab? You have 2x minus 4y, and this implies that if derivative x with the point what we have 2 and 3. Keep in mind, Shabab, x naught, y naught is equal to 2 and 3. Okay, خلاص ال x naught, y naught هو البوينت اللي احنا نبدأ منه يا شباب. 2 3. Okay, so we have this. So now this is equal to here you have 4 minus 12, so it is minus 8. Derivative f with respect to y, we have minus 4x plus 2y. So derivative with respect to y, 2 and 3 equals to minus 8 plus 6. So we have negative 2. طيب يا شباب. الآن delta z approximated by dz, which is approximated by. Now, شوف انتبهوا معايا يا شباب هنا ها. This here, which is this one. So we have minus 8. الآن هنا minus x naught. X naught is 2. What should I put here? Okay, let me continue here. Minus 2 minus y naught. Y naught is 2, so we have plus 2. Okay, so what should I put this for x and y? Shabab, what should I put here? Sorry, I made
2.05.
I made a mistake actually. So we have minus 3. Minus 3. Okay, yeah, so here I put 2.05. Well, here I put the other point, which is 2.96. Okay, هذه للX وهذه للY. Okay, now this is it approximately. Here we have minus 8 times 0.05, and then minus, of course, the difference would be plus 2 times 0.04, okay, because 3 minus distance, so we have this one. So here we have negative 0.4, right, plus 0.08, so we have negative. Okay, can you see, Shabab? Yes. What you have, Shabab? Negative what, Shabab?
0.32. 32.
Okay, so we have this. Okay, Shabab? And this is what we have it here. Any question here, Shabab? Remember the xy. The xy in the equation, it is the new point. يعني point after you move, after you move from x naught y naught to the new point x and y, it is this one. Okay. طيب, notice this يا شباب. This is a change in x. يعني هذا التغيير اللي صار في الاكس coordinate, which is 0.01. وهذا التغيير اللي صار في الواي. طبعا هي اصلا نيجاتيف. نيجاتيف 0.04, but I put the negative out here. Okay, so this is the change in x, this is the change in y that happened. And we approximate the change in z, we said approximately is equal this one. It's okay to find negative value. Right. The same question or the same idea goes for this one. Can solve problems related to the error. Related to the error here. So I remember we talked about this in just a few moments ago. The base of radius and height, the base radius and height of a right circular cone are measured as 10 centimeter and 25 centimeter respectively, with a possible error in measurement of as much as 0.1 centimeter in each. So he said use differentials to estimate the maximum error in the calculated volume of the cone. And then he said use differentials to estimate the maximum relative error and the maximum percentage error. Remember we took these in Math 101, but also the idea repeats in this course. So first of all, Shabab, we want to first of all, Shabab, we need to find the variables, huh? The variables. Now look here, he said circular cone, right? Circular cone. Okay, and he talked about the volume. What is the volume Shabab of circular cone? Can anyone remember? طبعا ايش تحتاج في السيركل كون؟ تحتاج radius اللي هي r والهايت اللي هي ايش؟ h. لو عندك radius وهايت يا شباب, what is the volume of the circular cone? By
باي ار سكوير في اتش.
في h cone.
هاف.
لا مو half.
over 3.
Over 3. Over 3. So we have it this way. Okay, over 3. So this is the volume. Okay. طيب يا شباب. Okay, if I can do it actually this one. Yeah. طيب يا شباب. So we have it here. Now, he asked me to find the error. The error in calculating, calculating the volume. Remember, Shabab, he said the radius, he found it to be 10, okay, if I'm not mistaken. Yeah, he told you 10 and 25, okay? 10, 25. So radius 10 and the height is 25, okay? And he said, well, there is plus and minus 0.1. Yani when he measured this cone, the radius, he found 10 centimeter, but there is a maybe plus and minus 0.1, and the same thing for this one here, okay? And then when you calculate the volume, it will not be exactly the volume when you consider this, right? It will be plus or minus something. So that's what we want to calculate, yani plus or minus what, okay? So so what we do is, Shabab, we want to find the delta V. We want find delta V. Okay. So delta V, ايش المقصود يا شباب دلتا في؟ يعني كأنك بتحسب الفوليوم لما يكون هذا الميجرمنتس، وتحسب الفوليوم لما تزيد او تطرح الميجرمنت 0.1 ماينس 0.1 من هذه، وتحسب من جديد. الفرق بينهم هو حيكون الايرور حقك يعني. اوكي؟ الفرق بين الفوليومز يعني. But he said the maximum error. في الماكسيمم ايرور يا شباب ناخذ ايش؟ ناخذ البوزيتيف. بوزيتيف 0.1 يعني اعلى ايرور ممكن تزيد معك يعني. اوكي 0.1. اوكي so this is what we are considering, that's why we are calling the maximum error. يعني كحد اقصى للايرور 0.1. It could be 0.005 يعني that's why, but we are considering the maximum one. The highest, he told you, the highest error cannot exceed 0.1, okay, or measurements as much as 0.1. So this delta V is equal EV, according to what we did before. وشوفوا يا شباب معي ال v هي عبارة عن function of f of r and h, a function of two variables. Function of two variables. So this is approximately equal. Now if I follow the rule, I will say derivative of f with respect to r at r naught h naught times r minus r naught plus derivative of f with respect to h r naught h naught times h minus h naught. اللهم التغيير اسماء يا شباب. ها we have this. طيب now what we need to do يا شباب, this is the v equal f of r and h, and let me write again by r square h over 3. And then we need to find derivative of f with respect to r, which will be 2 by r h over 3, and derivative of f with respect to h, which is equal to by r square over 3. This implies that derivative with respect to r. Now what is r naught and h naught يا شباب؟ مين ال R naught وال H naught يا شباب؟
10 و 50.
ايوه هذا R naught هذا H naught يا شباب. Okay, so now we have 10, 25, which is equal to, well, here we have pi, you have over 3, so يعني here you have 10 times 20, 250, so you have 500, right? Pi over, and not over, sorry, we have fh at 10, 25, which is equal to, now here you have 100 pi over 3, right? طيب, now let's go back to this equation here. Delta V is approximated by this guy, which is 500 over 3 pi times, and here we're going to talk about it, plus FH يا شباب, which is 100 pi over 3 times. Now look at here يا شباب. What is the change in R? لو كانت القراءة الأولى 10 يا شباب, وقال لك لا والله في زيادة 0.1, كم الفرق بينهم حيكون؟ 0.1. هذا هو التشينج ان R. نفس الشيء يا شباب, change in H حيكون كم؟ You know, he gave you in the question also 0.1. Okay, so what should I put here? What should I put here يا شباب؟ 0.1. Okay, 0.1. هنا التغيير بالنسبة للR والH. Okay, طيب, so when I put 0.1 you have 50 over 3 pi plus 10 over 3 pi, and you can put it this way here. طبعا لما تجمع هذه شباب عندك 60 over 3 pi, which is 20 pi. 20 pi. Okay, فالايرور maximum error is this 20 pi. Okay, طيب, هذا الماكسيمم ايرور. الان what is the relative error؟ يتذكر كيف كنا نحسب الريلاتيف ايرور؟ What is the relative error? I know you took it 1 year ago, so let me just put it this way here. Remember يا شباب, delta V اللي هي maximum error, we said approximately 20 pi. طبعا هذا هو الدي في على فكرة. طيب, relative error it's equal to delta V over V. كده ناخذ الماكسيمم ايرور ونقسم على الفوليوم الاساسيه. So and this is dV over V. طيب, الدي في هذا, طيب والفي يا شباب V equal by R square H over 3. So this implies that V equal by, طبعا حطوا بالكم شباب ال R naught ال H naught equal 10 25. راح نعوض هنا شباب يصير عندنا 100 times 25 over 3. So we have 2500 pi over 3. Okay. Now the relative error, which is approximately by dB over B, which is equal to 20 by, وهنا عندك 2500 over 3 pi. Okay. Simplify this guy, you do the fraction, and I believe I wrote the answer, final answer, which is this one here, 0.024. Okay. طيب الماكسيمم percentage, sorry, my typo here, maximum percentage error. Okay, let me just change this one. Percentage error. Okay, yeah, maximum percentage error. You just multiply by 100%, so you get 2.4%. And you are telling the people that, well, when we calculated the volume, there is a mistake of 2.4%. Okay, 2.4%. Any question here, Shabab? That's it for this section. I went slow in this section just to explain these ideas, because the differentials, we're gonna need it, Shabab, later. The differentials, these are important here, and also the tangent plane is important because we are coming, maybe not in this course, but maybe later in future you need it. The tangent planes. Okay, these things. You might need it later in the future. طيب, any question?
We did not start 14.5, right?
No, we did not stop 14.5.